Hello, I'm John Excel, editor of The Engineer, and welcome to the latest episode of The Engineer Talks, a series of short video interviews in which we talk to experts from across the world of engineering and technology about some of the key trends and topics that are shaping industry. This episode is the latest in a series of discussions around the net zero debate. Now, when we explore the push for net zero, our focus on the engineer is often on the individual technologies and innovations that are going to get us there. And there's no doubt that engineering innovation and technology are absolutely key. But if these technologies are really going to deliver on our ambitions, they really need to be part of a joined up solution that's underpinned by a rigorous scientific approach. And that's what we're here to discuss today. My guest is Richard Barker, a physicist who's the head of energy and environment at the National Physical Laboratory. And we're going to be talking about how science, and particularly the science of measurement, is critical to ensuring that all of the technology innovation around net zero actually adds up to something meaningful. Richard, good to see you.
Yep. Hello, John.
Hopefully that introduction
that works for me. Yes.
Good. So before we get into the main discussion, could you just sort of briefly introduce yourself and your role at NPL?
Yes, sure. So as you mentioned, I'm the head of energy and environment, and really my role is to try and figure out what is the science that we need to help us deliver on societal ambitions. And obviously with my title, you'll expect that climate change is one of the big focuses there. And I look at both sides of it. So I look at the problem, do we understand the problem well enough? And then also the solutions in terms of innovation and technology, whether they're actually going to deliver and solve that problem. So I kind of get to look at both sides of the equation there.
Right. So I mentioned in my intro there the importance of taking this, this sort of overarching systems level approach. But it would be really good to get your view on that when we're looking at the net zero challenge. How important is this joined up approach?
Yes, no, absolutely. So, a lot of the time people will say, I'm doing something for net zero. And of course, the issue is there's no, I think as you highlighted at the beginning there, no single thing on its own can deliver it. Net zero really means the totality of everything that we do, okay? And so it's very easy to pursue particular innovation thinking this is a net zero innovation, but it won't actually deliver on net zero because it doesn't all add up. And this is really where this kind of systems approach to net zero starts to come in, because if you look into the problem a little bit and how do we get our emissions down to net zero, it's an incredibly complex problem with a lot of dependencies there. So wherever you touch one part of the system, there'll be consequences elsewhere, and you kind of need to follow that trail to make sure that it all adds up. And so that's really the big challenge that I'm concerned about, because obviously I'm not an engineer or a technologist myself, so I'm not going to be focused on a particular technology, but I see my role is trying to ensure that the whole thing does work together. Yeah,
and to get that to happen, I guess that dialogue between the engineering industrial community and the scientific community is absolutely vital.
Absolutely key, yes. And we do, at NPL, we do a lot of work working with industry. One example I can give at the moment is around batteries. And, if we take, for example, I think this is a good illustration of batteries. I'm starting to see now in some battery electric vehicles, it says zero emissions vehicle there. And so, it'd be tempting to say, oh, that's going to be net zero. But of course, it's not. At the most basic level, there's no emissions at the vehicle, but you've still got to produce that energy. And so I think it's fairly obvious to people that actually it only is zero emissions if we're producing that energy through renewable energy, for example. But of course, then you've got issues with the batteries themselves, and how do you make those batteries and how do you dispose of those batteries? And so the trail that you start to follow, where you have to address issues along this entire supply chain, both upstream and downstream, to make sure that the whole thing adds up to net zero. And I think one of the challenges that we have is in a lot of areas, we cover much of the supply chain, but maybe there's some areas that we don't.
Yeah.
And of course, net zero overall means we have to hit everything. Now, we know there are some areas of society and the economy and technology that we can't decarbonize. So we are already dependent on carbon capture to a certain degree. But of course, we need to minimize that. So we need to look at everything there. So, as an example, one of the things that NPL is doing a lot of work at the moment is looking at the degradation mechanisms within the electrochemistry of batteries.
Right.
Because if we can extend the life of the battery, that makes a significant difference to that whole life cycle in terms of how close to net zero we can get.
Interesting. And I mean, it's a good example, the sort of vehicle electrification thing. Obviously, it's a kind of, a huge trend at the moment that's completely transforming, one of the biggest sectors based on the sort of the dialogue and the conversations that you're having with people in that area. Do you think there's an appreciation within that sector that we need to be taking this, this systems level approach?
Yes, I think there is growing appreciation, and I think some of that appreciation has actually even just been driven through more traditional challenges about raw materials. So I'm sure a lot of people will be aware that cobalt at the moment with current battery chemistry is a really important ingredient, and there is not an unlimited supply of it. So at the moment, we have a minority of vehicles with batteries. If we look to the future where we want all cars potentially to be battery powered, we're going to have a shortage of resources to do that. So we need to be better at recycling the materials that we've already got out of the earth. So yeah, I think there is growing awareness of that. Obviously, you can only tackle this one stage at a time, but it's certainly from my perspective, it's about understanding the totality of what you need to do, even if you can't do it all just yet.
Yeah,
we're not
sure.
going to make this transition in one go.
Yeah, and I mean, obviously, it's kind of incredibly complex. But we were talking before, and I think one thing that it's worth stressing is that there is a commercial imperative for companies and organisations and industries to be thinking in this way, isn't there?
Oh, absolutely. Because if we didn't have this climate problem, we wouldn't be trying to pursue net zero as an ambition. We wouldn't be looking to pursue so many of these low carbon technologies. So the reason why we're doing it is because we want an outcome of net zero to try and avoid the catastrophic consequences of climate change. Yeah. And so it's really important that we don't invest and innovate in technologies that actually don't deliver overall. Now, that's important for the UK because we want to be able to export our technologies. And climate change is a global phenomenon. Many, many countries are pursuing low carbon paths to try and support the global ambition towards net zero. And so what we want to be doing in the UK is making sure that one of our differentiators is we figured some of this out. We create technologies that are truly part of a net zero system and can help everyone deliver on net zero.
Yeah, yeah.
And I think that's going to be really important in the future because net zero isn't just, if the UK hits net zero, we're not going to solve the global climate change problem. We need all countries to. And of course, the UK is one of the, not so many very advanced countries in terms of engineering and technology. So we're going to have to support other parts of the world. We're going to be creating export industries there. So I think it's important that we can also differentiate what we do by understanding this kind of broader context.
Yeah, sure. I'd like to go back to this point around the sort of the importance of the dialogue between the scientific community and the engineering community, and how your world can help help industry address some of these challenges. Could you expand on that a little bit, and perhaps specifically the role of NPL in helping address that?
Sure. So one of the challenges that we have in science is there's just simply so much science to do. We can't do it all. We don't have unlimited resources, and we need to focus our efforts. And what we're finding with both net zero, the broader problem in terms of, for instance, measuring the climate or measuring greenhouse gas emissions or validating that technologies work, is that it's so complex. A lot of these situations in what we're trying to understand, and does it deliver on the end result? The biggest thing for us to know is what's the question we really want to answer?
Right. Yeah.
Because it's very easy for science to provide lots of data, lots of information about things that people look at and think, okay, but I need to do this. Okay. And so one of the challenges that we have in the science community is to understand what are the questions that people really want to ask. And often people won't know that question. There's an element of science and discovery that needs to be done to actually understand what is the real question we're trying to ask. And so that's why, from my perspective, it's really important that we have this dialogue, not just with policymakers, but also the technologists, to make sure that we understand what's the science that we need to do to support that. And that's particularly a case for NPL. It's the National Physical Laboratory. So we are funded significantly by government, and we're in the very fortunate position of being able to choose What is the science that we need to do? And so part of my role is to take that view and say, how can I benefit the UK most? So which science should I focus on? And so that's a big challenge for me, but I can only really solve by having lots of interaction with lots of different stakeholders. And of course, given we've got this net zero challenge, part of my job is then trying to connect all these different stories of different stakeholders together to figure out, this is the science underneath it that actually can support everyone.
Right, see, yeah.
One stakeholder might not be obvious what's the right science that they will need to support them.
Yeah, yeah. And I mean, the other thing that's sort of worth stressing is the science of measurement and is kind of vital, isn't it, to helping organizations, companies, industries have a well-rounded understanding of the big picture, if you like.
That's absolutely true. So a big part of NPL's role, so we are what's called the National Measurement Institute. And so we have a very, very specialist role because, of course, scientists and engineers throughout the world, everyone is measuring. But our role is quite specific. Our role is to figure out how close to the truth do we think measurement is. So we start with the basic assumption that measurement is actually just an approximation of reality. And so the science we do tries to characterize and look at the uncertainty in any measurement to kind of assess, well, how close to the truth do we think that is? And we're set up to do that because we have other organizations around the world where we regularly agree to measure the same things and we compare our results. And traditionally, this is very much focused on what we would call precision accuracy. And we would measure, for instance, the meter or the second to a tiny, tiny level of precision. But of course, for many applications, that's just not relevant anymore. Actually, the problem that you have with a lot of the challenges that we face in society today is not one of precision, but is an issue of complexity. And how do we represent that complexity in measurement? So if I take the easy example, because we know it's very complex, is the climate itself. So what are the measurands of the climate and how well do they actually represent what the climate is doing? And of course, this becomes really difficult when you don't understand the whole system you're dealing with. And we don't understand the whole of the climate. We understand a lot, but we don't understand it all. And so that's a really, really challenging problem for us. And we see this problem also happening down at the individual innovation level. So I've mentioned batteries earlier. So we're looking at, how do you in situ measure the kind of degradation mechanisms that are going on within a battery? And the challenge you've got there is in measuring, you don't want to interfere with those processes. But also, even at that small scale, they're very complex processes there where a lot of our measurement is also reliant on modeling at the same time as well. You can't just measure on its own. And so this is where I hope you could see that, this simple principle of measuring, getting a tape measure and measuring something translates into something that's incredibly complex.
Yes, yeah. And also, I mean, just sort of going back to the earlier question, this using measurement to enable companies or industries to have a kind of a well-rounded view is critical to kind of helping people understand what it is that they've actually got to do, what the big challenge is.
Yes. I mean, I think in anything, in any innovation, you want to know that it works. Okay, and effectively, measurement is part of that feedback loop that says you try something, you measure it, you see how it works or doesn't work, you learn from that, innovate a bit more. And so I think, a lot of people appreciate that innovation is quite a long process. It's not something that happens very, very quickly. Yes, the initial idea might suddenly come out, but actually to get it to be a usable technology for society takes an awful lot of effort. So that's the kind of iterative approach that I think needs a feedback loop, and measurement is the main way that we see that people need to create these feedback loops.
Yeah, sure. So obviously NPL is doing a lot of work on this. Could you give us a bit of insight into how you're actually sort of helping drive the science of measurement to make that big picture possible and to make those make those measurements possible?
Yes, so I think there's a kind of a combination of things that are going on here. One is we are constantly on the lookout for new technologies, new sensors that gives us new abilities to measure things. So, if I talk about the big picture, for example, and measuring the climate's such a huge scale that we're really looking at things like satellites and Earth observations and the capabilities that we can do to understand the climate at that macro scale. So there's new technologies. I think I've also then mentioned models. So models help us understand what is actually happening there and gives us the context of those measurements. And so that's also now a field, and we will work, because we're not generally modelers ourselves, we will work with other organizations. So if I take climate, it would be someone like the Met Office, right, to really look at how do we bring together measurements, so that's what we've actually observed with models, how we understand it all interacts, and make sure that they're coherent.
Yeah.
You do get these challenges. You measure something and you have a model, and the model might say that measurement can't be right. It doesn't fit with the model. So then we have to go through this process of understanding the two. So really for us, measurement moving forward is a combination of technological and scientific progress in both the technical and also the theoretical domains. Yeah, and I think that's quite important as we move forward, because we do start to ask ourselves, what is the question we're really trying to answer? And often that is not clear.
Yeah. So from your point of view, it's not just about kind of developing technology, but it's about finding ways of using systems that are already out there that are acquiring data, whether it be satellites or weather observations, a whole range of different things.
Yes. And I think one of the challenges that we then face is, through science we can bring together lots of information. I think I alluded to this earlier. It's then, how do we make that useful to people? How do we make it motivating and engaging? And this is a problem I've been thinking about in terms of systems challenges, because most systems that we have created have kind of evolved. They've kind of been an emergent system. Whereas with something like net zero, we've got a deadline. And we've also got a very specific objective, but it's not necessarily a particularly motivating or tangible objective. We can't sense when the greenhouse gases are high in the atmosphere. Without science, we wouldn't have even perceived that we've got a climate change problem. We would just thought, it's been a bad year for weather, for example. So when I thought about it, I think there's only one obvious example for me of a systems challenge that humanity has managed to tackle in this kind of deadline sense. And that would be the Apollo space mission. Right. Which was an incredibly complex problem. It brought together not just technologies about how do you get something to the moon, but also lots of technologies around how can humans survive? How do we feed people? How do they live in these very confined environments? And what's interesting about the Apollo space mission is, first of all, the objective was very clear, tangible, and motivating. And they almost had unlimited budget. So now, if we put this in the context of net zero, on the budget side, I think there's still challenges. We know that there's lots of competition for resources amongst governments, so we've still got some work to do there to free up enough budget to really be serious about tackling net zero. But actually, probably the bigger problem is, how do we make this objective more tangible and motivating so that we can create some focus here? And I think for me, this is one of the challenges of measurement. So science is very good at providing data, but that doesn't necessarily motivate, doesn't necessarily make it tangible. So going back to my earlier point about these very, very complex systems, it's how do we make that complexity simple and understandable and clear so that people know we're making progress, the innovation is working, we can invest more in this area, it does add up, it will deliver. So I think that's a really important question for us in science to be able to answer here, is how do we make what science observes tangible to the people that need to drive the change in innovation?
Yeah, great. No, really good example. And obviously measurement is absolutely key to building that understanding.
Yeah.
Excellent. Okay, Richard. Well, I think that's about all we've got time for today. It's been great talking to you. I think it's a really important part of the debate that perhaps can be forgotten about if you're an engineering innovator, sort of immersed in your own specific area. So thanks for offering your thoughts today. Hopefully it'll help encourage organisations to not to forget about that big picture view. And I would encourage you to get in touch with MPL. If you're watching this and you think Richard or the team there might be able to help, we'll flash up the contact details in a moment. For now, though, I'm afraid that's it for this episode of the Engineer Talks. Richard, thanks again for joining us today.
Thank you, John.
Thanks everyone for watching, and take care.